For number 45, we want to determine whether the series here is convergent or divergent by expressing it as a telescoping sum. So what we're going to do here is decompose this at first using partial fractions. So from infinity to 3 over n times n plus 3. And now let's take this 3 over n times n plus 3 and decompose it. So we want to decompose it into some constant a over n plus some constant b over n plus 3. And the way that we're going to do this is we are going to join this a over n plus b over n plus 3 and then compare it to the left hand side. So if we were to join this times n plus 3 into a single fraction, they would have the common denominator, which would be n times n plus 3, and then you would multiply a by n plus 3, a by n plus 3, and then plus b over n. So once we've joined these, we want to compare them to find the values of a and b. And we can see that the denominator is already equal, so we don't have to worry about it. So we can just erase that and purely focus on the numerator. Now, if this equation here is going to work, it has to work for every single value of n that you plug in. So what we're going to do here is we're going to choose strategic values of n that are going to help us eliminate some of these constants. So first let's choose n is equal to 0. And if we plug in n is equal to 0, we're going to get 3 on the left hand side is equal to a times 0 plus 3 plus b times 0, and that's going to eliminate b. So we're going to have 3 is equal to a times 3, which therefore means that a is equal to 1. So we have that a is equal to 1. That's our first constant. And now we're going to take the same equation and we're going to plug in minus 3 for n. So if we do this, we have 3 is equal to a times minus 3 plus 3, which is 0, plus b times minus 3. So if we simplify this, 3 is going to be a times 0, so that disappears, minus 3 times b, which therefore means that b is equal to minus 1. So once we have found these constants, we're able to replace them here. So a was 1, and then b was minus 1. So that is the partial fraction decomposition. And if you want to check this, you can add these fractions and you're going to see that that is in fact going to be 3 over n times n plus 3. So once we have found this, we can then rewrite this series here as the sum from 1 to infinity of 1 over n plus minus 1 over n plus 3. Okay, so we have done the partial fraction decomposition, but now what I'm going to do is I'm going to expand this series, this rewritten series here. I'm going to expand it up to n is equal to 6, just so that you guys can see what happens here to the patterns. So let's do up to n is equal to 6. So if you plug in, the index begins at 1. So for n is equal to 1, we're going to have 1 over 1 minus 1 over 1 plus 3, so 1 over 4. So we're going to have 1 over 1 minus 1 over 4. And then for n is equal to 2, we would have plus 1 over n, so 1 over 2, and then minus 1 over n plus 2, so n plus 3, so minus 1 over 2 plus 3, minus 1 over 5. So that's for n is equal to 2. Let's do n is equal to 3, so plus 1 over n, and then minus 1 over n plus 3, so minus 1 over 6, and then n is equal to 4, so 1 over n, so 1 over 4, minus 1 over n plus 3, so minus 1 over 7. So that was n is equal to 4. For n is equal to 5, we have minus plus 1 over 5, minus 1 over n plus 3, minus 1 over 8, and lastly, we need for n is equal to 6, so plus 1 over n plus 1 over 6 minus 1 over n plus 3, so minus 1 over 6 plus 3, which is 1 over 9. So what we've done here is we've taken this expression, 1 over n plus minus 1 over n plus 3. We've plugged in all the values from n is equal to 1 to n is equal to 6. And now let's take a look at what happens here. Well, we can see that this minus 1 over 4 is going to cancel out with this plus 1 over 4. We can see that this minus 1 over 5 is going to cancel out with that plus 1 over 5. And this minus 1 over 6 is going to cancel out with plus 1 over 6. So what are we left with? Well, we're left with 1 over 1, so 1, plus 1/2, and plus 1/3. And we can see that these are never going to be canceled out, because where we begin to subtract, so minus 1 over n plus 3, the first term that we get is minus 1/4. So that means that we're never going to be able to cancel out these three terms. And what we're left with is minus 1 over 7. And remember that n was equal to 6. So this minus 1 over 7, it should be minus 1 over n plus 1, because n is equal to 6. And then we have minus 1 over 8. So minus 1 over 8 would be n plus 2. And then minus 1 over n plus 3, because n is 6. Minus 1 over n plus 3. So that's for n is equal to 6. Now let's do the case where n is equal to 7, just to double check that that's going to be true. So if we add n is equal to 7, remember that the formula goes plus 1 over n minus 1 over n plus 3. So for 1 over 7, we would have to add plus 1 over n, so plus 1 over 7, and then minus 1 over n plus 3, so 1 over 7 plus 3 is minus 1 over 10. And then let's see if this formula holds. Well, if we do this, now we cancel out the minus 1 over 7 with plus 1 over 7, and we are left with minus 1 over 8, minus 1 over 9, and minus 1 over 10. Notice that now we have that n is equal to 7, so this minus 1 over 8 is minus 1 over n plus 1. This minus 1 over 9 is minus 1 over n plus 2. And this minus 1 over 10 is minus 1 over, it's minus 1 over n plus 3. So even if we expand now to n is equal to 7, we can see that the remaining terms, minus 1 over n plus 1, minus 1 over n plus 2, minus 1 over n plus 3, that's exactly what we got here. So we can see that the pattern here holds. This sum here, we're always going to have 1 plus 1/2 plus 1/3 minus 1 over n plus 1 minus 1 over n plus 2 minus 1 over n plus 3. So once we have found this formula, let me erase all of this stuff so that we have some space to work with. So we can now rewrite this whole sum here as being 1 plus 1/2 plus 1/3 minus 1 over n plus 1 minus 1 over n plus 2 minus 1 over n plus 3. So this here is the result of our sum. And now we want to calculate our sum not for n is equal to 6, not for n is equal to 7, but for n is equal to infinity. So what we're going to do here is we're going to take the limit as n goes to infinity of this whole thing here. So first let's join 1 plus 1/2 plus 1/3. And if we plug that into our calculator, I believe that that's going to be 11 over 6. Let me double check that. Yes, that is going to be, so this is 11 over 6. So we're going to take the limit as n approaches infinity of 11 over 6 minus 1 over n plus 1 minus 1 over n plus 2 and then minus 1 over n plus 3. And if we take this limit here, what we're going to have is, so that's going to be, the limit of 11 over 6 is just 11 over 6. And this is going to be minus 1 divided by infinity plus 1, which is minus 1 divided by infinity, which is minus 0. And then minus 1 divided by infinity plus 2. So that would be minus 1 divided by infinity, which is 0. And then once more, minus 1 divided by infinity plus 3, which is also 0. So actually, the end result of this entire sum is just 11 over 6. So that is it for problem number 45. We were able to take this series here, which is how it began, and then we decomposed it into partial fractions. And then once we expanded the partial fractions, we saw that the whole sum, it ends up being just this, because everything else, it cancels, right? And so once we found the expression for the sum, we were able then to just plug in, or take the limit rather, of as n goes to infinity. And once we found this, we found that every term that contains n is going to go to 0. So all we're left with is 1 plus 1/2 plus 1/3, which ends up being 11/6 over 6. So that's it for 45.